Hello everyone, today we are going to solve 10 statistical problem using Python. We will work with sampling, confidence intervals, correlation, covariance and even z-test. My question number 1 and question number 2 is first we take data from supermarket.csv and filter it for females. For Q1 we calculate the sample mean of unit female price with 500 samples, and for question 2 with 1000 samples. Sampling users understand how mean changes with the sample size. The larger the sample, the closer we get to the true population mean. And this is my third question. In question 3 we find the population mean that simplifies the mean of the entire data set for females. This serves as your reference for comparison. This is my output. This is my fourth question. Now, for question 4, we create 95% confidence interval for the sample mean from 500 samples using the formula with the standard error. We check if the population means lies within our confidence interval. If it does, it mean our sample mean is a good estimate. This is our sample mean. This is our fourth question. Now for fourth question, we create a 95% confidence interval for the sample mean from 500 sample using the formula with standard error. We check if a population means lies within our confidence interval. It does. If it does, it means our sample mean is a good estimate. This is our fifth question. In fifth question, we change the confidence level to 99%. This is widens the interval because we are more confident but less precise. Again, we check if the population mean falls inside. This is my sixth question. Sixth question is more visual. We run 25 trials of a sampling with n is equal to 500 and plot the confidence interval. Each blue line is a interval and each red dot is a sample mean, and the green dashed line is a population mean. This shows how sampling variation is work. This is our seventh question. In seventh question, we calculate the Pearson correlation coefficient between weight and blood pressure. Pearson measures linear relationship. If it close +1 or -1, the relationship is strong. This is our eighth question. In eighth question uses Spearman correlation, which rank is based and detects monotonic relationship, not just linear ones. It is useful when data is not normally distributed. This is our ninth question. Ninth question is about covariance and correlation heat maps. We calculate the covariance matrix for maths, English, and art scores. Then use Seaborn to plot the heat map of a correlation. This let us visually see which subject have a strong relationship. This is our output of the ninth question. This is my 10th question. Finally, in 10th question, we do a z-test. The population mean breaking the strength is 1800, but our sample of 50 cables has a mean of 1850. We calculate the z value and compare it with the critical value 2.33. 2.33 at 1% significance. Since our z value is greater, we reject the null hypothesis. The new manufacturing method likely increase the cable strength. Thank you.